for 10.4, we're going to look at hypothesis testing for a mean. The overall write-up is the same. Obviously, just a few things are going to be different. The conditions, though, so there's two tests with a mean. Just like there were two intervals, there's the Z and the T. I'm going to cover both as I go over this because remember, there's only one difference. Whether we know the population standard deviation or we know the sample. So like for your first condition, that's a 1, not an A. It should be X bar is from a random sample. Okay, that's always condition 1. Really, 1 and 2 of the conditions are really the only conditions. 3 and 4 I just put there. 2 is different than with a proportion, right? With a proportion, we did n times p, n times 1 minus p. For a mean, you just have to have n is greater than 30. Or, this is the one where the population distribution could be normal, given to you in the problem. On 10.4 day 2, we'll look at, again, what happens if you have data. Because you've got to do a box plot and all that fun stuff. Now, the difference in the testing. You're going to use let's see, this is 3. So if we know the population standard deviation, it's called a 1 sample Z test for mu. So that's if we know the population standard deviation. If we don't, if we know S, then we use a 1 sample T test for mean. So this one you're going to use more often. Because, like I said in Chapter 9, it's more likely that you're going to know the sample standard deviation than the population standard deviation. So that's your big difference between Z and T. Just like we talked about in Chapter 9. And then condition 4, mu equals whatever the true mean, whatever. Wait time. So, conditions, like I said, pretty much the same. Your null and alternate hypotheses, this time instead of a p equals, we just have mu equals some hypothesized value. So I want my average to be, I don't know, a score of a 3 on the AP test, whatever. I want my average weight to be 170, I don't know. Then the alternate is, again, you can do greater than that hypothesized value, less than, or not equal. When you list your data, you got to give me a few things. You got to give me X bar. You have to give me sigma or S. Either the population standard deviation or the sample standard deviation. Now, if you give me S, along with S, I need to see degrees of freedom, which again is always n minus 1. And then n and the alpha value. Alpha, really, you just have to list if it's given to you. Okay? Then draw your test. So you either have a one-tailed right. Remember, that's if you have a greater than. And you would either write Z equals something or T equals something. One-tailed left would be less than. And again, you either give me Z or T. And then the two tails greater than or less than. And you tell me Z equals some negative or T equals some negative, some positive. Then your formula again, they're pretty much the same. For your test statistic, x minus the hypothesized value divided by your standard deviation. Now, for the quiz, you don't necessarily have to memorize the formula. It is sort of on your formula sheet, just written weird. Down here, it says standardized, sorry, it's so blurry. It says standardized test statistic. It's your statistic, which, like, for tomorrow will be p hat. Here it's x bar. Parameter, p or mu, divided by the standard deviation of the statistic, which again is right here and right here. So you don't necessarily have to memorize the test statistic formula. It is on here, if you just know what these are telling you. Because then it's here. This is chapter 11. Okay? So again, they're pretty much the same. One just has sigma and one has us. And then you either, a z of whatever gives us a p-value of whatever, or a t gives us a p-value of whatever with degrees of freedom. So if you do t, you got to add in the degrees of freedom. And then your conclusion, remember the first sentence should say it's greater than or less than, and then reject, fail to reject, and then it appears. Whatever. Yes, David? It can just be DF. You do not need to write out the words. So the second sentence, like I said, should answer the question. Yeah. Okay, or tell me which way you're actually going with. Is it the null or the alternate? Okay. Let's look at example 1. So the biggest question people always ask me, that I always get every year, is what's the difference between a t-test and a z-test? So that's what example 1 wants you to figure out. A furniture company produces a mirror on assembly line. When operating properly, the assembly process will produce an average of 140 mirrors per day with a standard deviation of 20 mirrors per day. It's also known that the distribution is skewed left. In order to monitor the assembly process, 100 days are randomly sampled, and the number of mirrors produced each day is recorded. The sample mean produced, x bar, will be used to determine whether the assembly operation is working properly. Suppose you observe a sample mean of 138.5 for the 100 days. Is this evidence that the assembly process is producing too few mirrors on average? So do you use T or Z here? Z, because of this guy. Now, if I didn't give you this sentence, so we're going to use Z critical value. If I didn't give you this sentence, down here with the sample mean, I would have to give you sample standard deviation. I'd have to give you S. So that's how the big difference about how you know. Usually if I give you a sample standard deviation, I may not actually use the word sample, but if it comes along with the sample mean, you should know they're connected. Again, more often than not, you're going to use a T critical value than a Z. For proportions, you always use Z. Okay, let's do a write-up so you can see kind of everything to put together. And I do want to go over how do you find the p-value for Z's too. I mean T's. So the manufacturer of a special bolt requires that this type of bolt have a mean shearing strength in excess of 110 pounds. To determine if the manufacturer's bolts meet the required standard, a sample of 25 bolts was obtained and tested. The sample mean was 112.7 pounds. The sample standard deviation was 9.62 pounds. Use this information to perform an appropriate hypothesis test with the significance level of 0.05. So, before you even do the problem, especially when you get to like the chapter 10 test and you got more than one write-up, figure out what test you're going to use. So am I going to use Z or T here? T, because this is the sample. So this is going to be a T test. Okay. And what I usually tell you to do, like the last test of the semester is 5 write-ups. So my big advice is to go through each one and figure out what test it is first, and then go back and do them all. Okay, so for your conditions, I think the conditions here are bad. Is this a random sample? We don't know. Doesn't use the word random in it. So if not, you just say X bar is not from a random sample. Proceed with caution. We'll get to, in our conclusion, we'll have to write another sentence. Is n greater than 30? No. And it's not from a, can't think of the words. But yeah, normal distribution. And we don't have the data. So again, proceed with caution. 25 is less than 30. We cannot assume a normal distribution by the central limit theorem. Proceed with caution. Now, when you actually take the AP test in May, the conditions should be met. Like they'll give you the information where this won't happen. It just happens on notes and stuff. So we already said this is a one sample t-test for mean. And mu is the true mean shearing strength for this bolt. Type of bolt, whatever. Okay? Like I said, the conditions don't really change. So once you memorize them, it's pretty easy. Okay, so for the testing part, our null hypothesis is that mu is going to equal 110 pounds. What's our alternate here? What are we looking for? What are we trying to test? Yeah. Greater than, because it's in excess of 110. So, draw your picture and name it. This is a one-tailed, right? And then you're going to have t equals something once we figure out our test statistic. Okay, for your test statistic, list all your data. So we have X bar was 112.7, S is 9.62, N is 25, which means our degrees of freedom is what? 24. Alpha is 0.05. So, T is always your number, so 112.7 minus your hypothesized value, 110, over 9.62 divided by the square root of 25. Okay, everybody get your calculators out. I forgot to tell you that. So when you go to your testing part, it's the first two tests are what you're looking at today. Z test, T test. So if this was a Z, look what would happen. You want to go to the stats part. It would ask you mu sub 0, sigma, X bar. But we're not doing that one. So T test, go to the stats part. So again, your mu sub 0 is whatever your hypothesized value is, whatever your ho and ha are. So here it's 110. X bar is 112.7, 9.62, 25. And then this part, remember, should match whatever your alternate is. So our alternate here was greater than. So again, you can either calculate it or you can draw it. I hit draw. So it gives you a t value 1.4033. Our p-value is 0.0867. Now the reason I like to use a calculator a lot for this is because, like with t especially, the only formula sheet that you have for a t critical value is this page. And these are the p-values, but it only goes up by it doesn't go up very much. Like if I were to look up 1.40, I'd have to go to row 24 and get as close to 1.40 as I could. Well, it's somewhere in between 1.3 and 1.7. Closer to 1.3. So like your p-value is in between 0.5 and 0.1. So the table on the formula sheet is not as accurate as the calculator, which is why they don't mind if you use the calculator. Obviously for z, you can use the formula sheet anytime. But for t's, you'd only have to give me an interval in terms of your p-value. Here, it's more accurate. Okay? So, then write out your sentence. A t-value of 1.4033 gives us a p-value of 0.0867 with 24 degrees of freedom. The biggest mistake people make is they forget to put degrees of freedom. Okay, so is this greater than or less than our alpha value? Greater. So we're going to fail to reject. So our conclusion for this one's actually going to have 3 sentences, because we got to talk about how it wasn't from a random sample or greater than 32. So since the p-value of 0.0867 is greater than our alpha, we have evidence to fail to reject the claim that the true mean shearing strength is equal to 110 pounds. It appears the mean shearing strength is 110 pounds. Now we got to talk about the conditions. However, since this was not from a random sample, or a normal distribution, we are concerned about the validity of the test. That's a lot. So again, the first sentence I'm looking for your p-value compared to your alpha. Do you reject or fail to reject? Second sentence, tell me what it actually is. And then this one shouldn't be necessary on the test or the quiz. Okay, questions on means.